Time dilation: How relativity affects the flow of time. Title: Time dilation: How relativity affects the flow of time. Introduction. Word count: 150. Time is a fundamental concept that forms the basis of our everyday lives. It enables us to measure the duration of events, keep track of schedules, and anticipate the future. However, the concept of time becomes more complex when we delve into the realm of relativity, where time dilation comes into play. Time dilation is a fascinating phenomenon that occurs due to the effects of relativity. In his article, we will explore the concept of time dilation, understand its significance, and learn about its applications in our modern world. Understanding relativity. Word count: 300. Before delving into time dilation, it is crucial to have a basic understanding of relativity. In 1905, Albert Einstein introduced the theory of special relativity, which revolutionized our understanding of space and time. Special relativity states that the laws of physics are the same for all observers moving at constant velocities, irrespective of their relative motion. One of the most astounding consequences of special relativity is time dilation. Simply put, time dilation is the difference in the passage of time between two observers who are in relative motion or are experiencing different gravitational forces. This phenomenon arises due to the constant and finite speed of light, which is an essential postulate of Einstein's theory. Gravitational time dilation. Word count: 400. Gravitational time dilation occurs due to the influence of gravity on the flow of time. According to general relativity, which extends special relativity to include gravity, massive objects, such as planets, stars, and black holes, create a curvature in the fabric of spacetime. This curvature affects the passage of time around these massive objects. In simpler terms, if two observers are located in regions with different gravitational potentials, they will experience time passing at different rates. The observer closer to the massive object will experience time moving slower relative to the observer in a weaker gravitational field. This effect has been experimentally verified through atomic clocks placed in different gravitational potential. Velocity time dilation. Word count: 400. Velocity time dilation, also known as relative time dilation, occurs due to the relative motion of two observers. According to special relativity, when two observers are moving relative to each other at speeds close to the speed of light, they will experience time passing at different rates. This phenomenon is perhaps best demonstrated through the famous twin paradox. Imagine two identical twins, one staying on Earth while the other embarks on a high-speed space journey. Upon the traveling twins' return, they will find that they have aged significantly less than their stationary sibling. This time discrepancy arises due to the difference in relative motion between the two observers. Applications of time dilation. Word count: 300. Time dilation, while fascinating to ponder, has real-world implications and applications. One practical use of time dilation is in the navigation systems of global positioning satellites, GPS. Failing to account for these relativistic effects would render GPS systems significantly inaccurate. Furthermore, relativistic time dilation has profound implications for the study of cosmology. By observing the light emitted from distant celestial objects, astronomers can measure the rate at which the universe is expanding. However, accurate measurements require considering the time dilation effects due to the immense gravitational fields around massive objects, such as galaxies or galaxy cliffs. Tears. Relativity, with its concept of time dilation, has had a profound impact on our understanding of the universe and has numerous practical applications. This phenomenon occurs due to the effects of gravity and relative motion on the passage of time. Gravitational time dilation, as predicted by general relativity, occurs when massive objects create a curvature in spacetime, resulting in variant ions in the flow of time. Observers in stronger gravitational fields experience time passing slower than those in weaker fields. This effect has been confirmed through experiments using atomic clocks. Velocity time dilation, on the other hand, is observed when two observers are moving relative to each other at speeds close to the speed of light. According to special relativity, time will appear to pass differently for these observers. This is famously demonstrated through the twin paradox, where a twin traveling at high speeds will experience less time passing than the twin who remains stationary. The practical applications of time dilation are significant. GPS navigation systems rely on precise timing to provide accurate location information. Since the satellites orbiting Earth are subject to less gravitational influence than observers on the planet's surface, their clocks run slightly faster. Failing to account for gravitational time dilation would result in inaccurate positioning. Additionally, the study of cosmology benefits from understanding time dilation. By considering the effects of time dilation in their measurements of distant celestial objects, astronomers can more accurately determine the rate at which the universe is expanding. These relativistic effects are crucial to obtaining reliable data. Time dilation, a consequence of relativity, is a captivating phenomenon that affects the flow of time. It occurs in two different forms: gravitational time dilation and velocity time dilation. Gravitational time dilation is influenced by gravity and occurs when there is a difference in gravitational potential between two observers. The observer closer to the massive object will experience time passing slower compared to the observer in a weaker gravitational field. This effect has been confirmed through experiments with atomic clocks. Velocity time dilation, on the other hand, occurs due to the relative motion of two observers. According to special relativity, when two observers are moving at speeds close to the speed of light relative to each other, they will experience time passing at different rates. One of the most famous examples of velocity time dilation is the twin paradox, where a twin traveling at high speeds will experience less time passing than the twin who remains stationary. The applications of time dilation are numerous and significant. GPS navigation systems rely on precise timing to provide accurate location information. Since the satellites in orbit experience weaker gravitational forces than observers on Earth's surface, their clocks run slightly faster. Failing to account for gravitational time dilation would result in inaccurate positioning. In cosmology, time dilation plays a crucial role in measuring the rate of expansion of the universe. Astronomers consider the effects of time dilation due to large gravitational fields when observing distant celestial objects. These relativistic effects are essential for obtaining reliable data. Time dilation is a phenomenon that occurs due to the effects of relativity and affects the flow of time. It can be categorized into two forms: gravitational time dilation and velocity time dilation. Gravitational time dilation is influenced by gravity and occurs when there is a difference in gravitational potential between two observers. The observer closer to a massive object will experience me passing slower compared to an observer in a weaker gravitational field. This effect has been confirmed through experiments using atomic clocks. On the other hand, velocity time dilation occurs due to the relative motion of two observers. According to special relativity, when two observers are moving at speeds close to the speed of light tied to each other, they will experience time passing at different rates. Perhaps the most famous example of velocity time dilation is the twin paradox, where a twin traveling at high speeds will experience less time passing than the twin who remains stationary. The practical applications of time dilation are significant and far-reaching. GPS navigation systems, for instance, rely on precise timing to provide accurate location information. Since the satellites in orbit experience weaker gravitational forces than observers on Earth's surface, their clocks run slightly faster. Failing to account for gravitational time dilation would result in inaccurate positioning. In the field of cosmology, time dilation plays a crucial role in measuring the rate of expansion of the universe. When astronomers observe distant celestial objects and measure the light emitted, the